We're going to take a peek at if the a value is some other number. But we still want the two factors to multiply to give us c. That has not changed. But now that we have a value in front of the x, it's not just x times x is x squared. It's some number x and some number x gives us some number x squared. So you also want to look at those factors, and those need to go in front of your x's. This last part is what would happen if you were to do that distributive property. You would take dx times g and get dgx, and then you would take e and fx and you'd get efx. Both of those have x's, so they would go together. And that's where that second number is going to come from. Now, for the most part, you are just going to, it's a little bit of guess and check. We want to be somewhat educated. For the most part, you're just going to be putting the numbers into the spots of the binomials and just checking to see if it works. For this first one, I'll show actually doing that distributive property for the check. First thing, do they have anything that can come out of all three of them? No. So we are going to jump into our two binomials. Now put in what you know. You can either start with the a value or you can start with the c value. I'm going to start with the a value. It is 2x squared. So the only way to get 2x squared is to have a 2x and a 1x. Which is going to give us 2x squared, or a 1x and a 2x. The next part, we look at the c value. C value is 3. How can we get 3? 3 is either a 1 and 3 or in 3 and 1. So I'm going to kind of walk through the two ways that this can be done so you can see why it does, the order does matter. All positives in this problem, so you're going to have all plus signs. So one of these answers is correct. One of them is incorrect. We know that that part should be good because we already set that part up. 2x times x, write this one on the top, 2x squared. 2x times 1, 2x. 3 times x, 3x. 3 times 1, 3. These are our like terms. Those give us 5x, which is what we want. So this is the correct answer. Why is this one different? You're still going to get 2x squared. You're then going to get 6x, 1x, and you'll still get that 3 at the end. So these like terms actually combine to 7x. And we run through our steps. Nothing in common with the three terms. No numbers, no variables in common. So we're going to go to our two binomials. Looking at the a, it's a 3. So to get 3, it's got to be a 3 and a 1. Now we look at the c. It's a negative 4. So it's got to be a positive and negative. So this is where it gets a little trickier. Positive could be here. It could be here. And possibly our numbers could be flip-flopped. So that kind of increases the different ways that this could be written. So that check is really, really important. How can I get negative 4? Negative 4 can be negative 1 and 4. It can be 4 and negative 1 because that will be different here. It can be 1 and negative 4. It can be negative 4 and 1. If I write those all out. But we also have 2 and 2. Now those can be flip-flopped and be the negative in the second spot. There's not 4 because it is the same term. So those are our options. There's actually 6 that we could try. We know we're going to take this 3x times this value over here. We know we're going to take this value times this x. And that's what's going to give us that middle term. So when I look at it, 3 times 4 is 12. That's pretty close to 11 versus 3 times 2 is only 6. So we won't go through all the options, but just thinking that way, I know it's not going to be these 2's. So let's look at the 4's. 4's and 1's. If I take the 3 times the 1 and the 4 times the 1, that's only going to give me either 7, negative 7, 1, or negative 1. We're looking for 11. So with practice, you'll get a little bit better at this, but I know I want to get a big positive number. So I'm going to take 3x and positive 4, which is going to leave me with the negative 1 being here. And we can check it real quick. Combine our like terms. Gives me 11x. So we have 3x squared plus 11x minus 4. So this is the correct answer. I did it on the first go. That doesn't always happen. You might need to flip-flop your negative. You might need to put the 4 in the other spot. Sometimes the a value will have more than one option as well. So then you have to play around with that. Now we have a 6 in the a spot. So that could be 6 and 1, 2 and 3. So I could start there, totally okay. But remember, it's educated guess and check. So if I look at the C value, it's a 5, a -5. That is a prime number. So there's less options there. And so I'm going to actually put that number down first, and I'm going to work towards getting my coefficient on the x. Now there is some more challenging parts to this because it does need to be negative because it is a -5. So one of these has to be negative, one of them has to be positive. We can use some hints to our advantage. -29 is a pretty big negative number. So I'd probably want to be multiplying that by the 5 to get a bigger negative. This is, again, with practice, you realize where the positives and negatives need to go. I know that's going to be correct. If you didn't, you would just go through the problem, check it, does it work? Moving on to the second part, we need some numbers in front of these x's. We want it to come out to be 6 when we take the x times the x. We want 6x squared. But then we also want to get -29 when you do the rest of the steps. So that's going to give us, we could do 6 and 1, 1 and 6, 2 and 3, 3 and 2. -29 is close to 30. 5 times 6, 30. So I'm not going to go through all the wrong answers. I know I want to take 5 times 6. So in terms of our distributive property, I'd want this to be occurring. A -5 and a +6 is -30. But we want to get -29, so you have to add 1, which means you'd have to take 1 times 1. And so there's our final answer with no work. It's all mental. One more example. Now, why is this one so tricky? Why is this the last example? 12 is not a prime number. 10 is not a prime number. So there's a lot of possibilities of different ways to get 10 and different ways to get 12. And we got that negative thrown in there for the -23 and the different orders. Because I know the answer, I'm going to not show as many possible wrong guesses. But if I think through what's going to happen, I'm either taking the 10 and the -12, the 1 and the -1, or 10 and the -1, 1 and the -12. And I'm trying to get -23, so I can kind of think through them and then write the answer down. So we have 10 and -12, which is -120. That's already way too big. That's not an option. If I do 10 and the 1, that's 10, -10, and -12, which is -22. It's really close, but it's not right. But I'm going to move on to the next one. So that'd be 10 and -6, -60, and -2, -62. No. -20 and -6, -26. Close, but no. Last set, 10 and 4, -40, and -3, -43. No. -34. No. These are not the answer. So it's got to be the 2 and the 5. So if I really wanted to, I could put those down right now. We also know that it's going to be 2 negatives, so I can put those down right now. And let's run through that same stuff. I'm going to take the 2 times the 12, -12. That's -24. 5 and 1 is -5. That's -29. That is not correct. I can flip-flop them, and I could take the 2 times the 1, which is 2, 5 times the 12, which is 60, -62. Also not correct. 2 and 6, 12, 5 and 2, 10. That would give us 22, -22. Nope. Flip-flop them. 4 and 30, -34. No. All right. We're down to the last two possibilities. Either the 4 is here or the 4 is here. So if we go 2 times 4, 8. 5 times 3, 15. 8 and 15 is 23. So we want to take the 2 times the 4. So we'd want the 2 times the 4 over here. We'd want to take the 5 times the 3 right here. And then the rest of the stuff would work out if you went through the distributive property. This last example is, it's challenging. It takes some time. You have to have a firm grasp of what's happening when you do that distributive property. So this definitely falls into the category of, the more challenging questions. Don't start with these. Be really solid on the ones where the A value is a 1, and then move on to when it's not a 1, but we have some primes in there, so there's not a whole lot of options. And then you can move on to these ones that have lots of combinations.